Hello everyone, in this video I am going to talk about hydro energy. So first, what is hydro energy? Hydropower or hydro energy is a form of renewable energy that uses the water stored in dams as well as flowing in rivers to create electricity in hydropower plants. It refers to the energy, mostly electric, which is derived from water in motion. This power is harnessed and used to drive mechanical devices. The main advantage of this form of energy is that it is clean and renewable. Hydropower plants are actually based on rather simple concept. Water flowing through a dam turns a turbine, which turns a generator. So next, what's inside a hydropower plant? The first one is the reservoir. The function or purpose of reservoir is to store the water during rainy season and supply the same during dry season. This is in simple water storage area. The second one is the dam. The function of dam is to increase the height of the water level behind it, which ultimately increase the reservoir capacity. The dam also helps in increasing the working head of the power plant. Dams are generally built to provide necessary head to the power plant. The next one is the penstock. Penstock is a pipe between the surge tank and the prime mover or turbine. The structural design of the penstock is same as for any other pipe, except it has to bear high pressure on the inside surface during sudden decrease in the load and increase in the load. Penstock are made of steel through reinforced concrete. Penstock are usually equipped with the head gates at the inlet, which can be closed during the repair of the penstock. A sufficient water head should be provided above the penstock entrance in the forebay or surge tank to avoid the formation of vortices which may carry air into the penstock and resulting in lower turbine blade efficiency. The next is the spillway or the outflow from where the water will go away. The function of spillway is to provide safety of the dam. Spillway should have the capacity to discharge major floods without damage to the dam and at the same time keeps the reservoir level below some predetermined maximum level. The powerhouse. A powerhouse consists of two main parts, a substructure to support the hydraulic and electric equipment and a superstructure to house and protect this equipment. The superstructure of most power plants is the building that house all the operating equipment. The generating unit and the exciter is located in the ground floor. The turbine which rotates on the vertical axis are placed below the floor level, which those rotating on a horizontal axis are placed on the ground floor alongside of the generator. The next one is the turbine or hydro turbines. The main function of hydro turbines is to convert the kinetic energy of the water into the mechanical energy to produce the electrical power. The turbines which are in common use are Peltonville, Francis turbine and Kaplan turbines. So now let's know about the working of hydropower plant. The basic requirement of a hydroelectric power station is a reservoir, where large quantity of water is stored during rainy season and used during the dry season. The reservoir is built by constructing a dam across the river. The water from the reservoir is drawn by the forebay through an open canal or tunnel. The water from the forebay is supplied to the water prime mover through the penstock, which is located at the much lower level than the height of the water in the reservoir. Thus, potential energy of water stored in reservoir is converted into kinetic energy and made to rotate the turbine. Turbine shaft is connected to synchronous generator or alternator for generating electricity. This generated power is stepped up using step-up transformer and delivered to load centers or grid. The regulation of water flow to the turbine depending on the electric load demand is carried out by the governor system. So now let's go to the next slide and know about the types of the hydropower plant. So basically there are three types: impoundment. So an impoundment facility, typically a large hydropower system, uses a dam to store river water in a reservoir. The water may be released either to meet changing electricity needs or to maintain a constant reservoir level. The second one is the diversion. A diversion, sometimes called run of river facility, channels a portion of a river through a canal or penstock. It may not require the use of a dam. The third is the pump storage. When the demand for electricity is low, a pump storage facility stores energy by pumping water from a lower reservoir to an upper reservoir. During periods of high electrical demand, the water is released back to lower reservoir to generate electricity. So let's go to the next slide and know about the social issues which are generated during the construction of the hydropower plant. So the problems such as relocating people from the reservoir area is the most challenging social aspect of hydropower, leading to significant concern regarding local cultures, religious beliefs, and effect associated with abandoned burial sites. While there can never be a 100% satisfactory solution to involuntary resettlement, enormous progress has been made in the way the problem is handled. Let's know about the significance of the hydroenergy. Hydroenergy or hydropower stands as the most significant renewable energy source. It uses the single but very powerful energy force of moving water. By some comparisons, it competes with the energy produced by fossil fuel and nuclear power, but is considered much cleaner and more simplistic. Hydropower remains popular even in third world countries such as India, which do not have the resources to build expensive nuclear generating stations. Hydropower does not pollute the atmosphere or environment. Let's know about the facts of the hydroenergy. Hydropower uses the energy of moving water for a variety of useful applications. Hydroelectricity generates electricity by harnessing the gravitational force of falling water from the reservoir. In 2014, hydroelectricity supplied around 16.4% of the world's electricity. Most hydroelectric power stations use water held in dams to drive turbines and generators, which turn mechanical energy into electrical energy. The largest hydroelectric power station in the world is the Three Gorges Dam in China. Now let us know about the economic impacts of the hydroenergy. Large dams have long been promoted as providing cheap hydropower and water supply. Today, we better know the cost and poor performance of large dams were in the past largely concealed by the public agencies that built and operated the projects. Dams consistently cost more and take longer to build than projected. In general, the larger a hydro project is, the larger its construction cost overrun in percentage terms. So now let's discuss about the advantages of hydro energy. Once the dam is constructed, electricity can be produced at a constant rate from hydro energy as the fuel is free. If electricity is not needed, the sluice gates can be shut, stopping electricity generation. The water can be saved for use another time when electricity demand is high. Dams are designed to last many decades and so can contribute to the generation of electricity for many years. The lakes that form behind the dam can be used for water sports and other activities. Often large dams becomes tourist attraction in their own right. Of course, the lake water can be used for irrigation purposes and many more also. As there are some advantage, and it also have some disadvantages also. Some are dams are extremely expensive to build and must be built to a very high standard. The high cost of dam construction means that they must operate for many decades to become profitable. The flooding of large area of land means that the natural environment is destroyed. People living in villages and towns that are in the valley to be flooded must move out. This means that they lose their farms and businesses. In some countries, people are forcefully removed so that hydropower schemes can go ahead. The building of large dams can cause serious geological damage also, like the earthquake. So that's all from me about hydro energy in this video. Thank you.